Oak Ridge National Laboratory electrochemist Adam Rondinone describes his nanotechnology research and explains how it might help to address energy challenges.
Nanotechnology is a field of material science where we take common materials that we know about in everyday life, plastics and metals and ceramics and things, and we make them very, very small so that they start to take on the properties of molecules. And so this is kind of the intersection of normal chemistry and material science or metallurgy. And what's interesting is when you take a normal material and you scale it down to something very, very small, cluster of a few atoms, for example, it takes on new properties. So in that sense, it becomes a new material. So if we think about gold, gold's a classic example of this. Gold as a metal is so unreactive, we find it in nature as a metal. We make jewelry out of it. We coat our contacts with it for your high definition audio headphones so that they won't corrode. Very, very unreactive. But as it turns out, if you take gold and you make it into a nanoparticle, that is a clump of just a few atoms, it becomes a potent catalyst for chemical reactions. And this is just a great example of how we can take common materials that we know everything about pretty much at this point, change the scale to make them very small, and really it's a whole new material. My personal research is about how to take the principles of nanotechnology and solve energy problems. And so we study electrochemistry. It's familiar to people in the form of batteries and fuel cells. And so we basically are developing new types of energy storage and conversion systems based on nanotechnology. We're best known right now for a reaction that takes carbon dioxide, which is a pollutant, and converts it into ethanol, which is a commodity, and it does so at very high yield and high efficiency. And that process is actually being commercialized now.